Welcome students. Let us see the continuation of nucleophilic addition reactions of carbonyl compounds. The first one is reaction with ammonia. Ammonia, that is NH3, when it is react with acetaldehyde CH3, C double bond O, H, it gives acetaldehyde ammonia, that is CH3 COH. This is NH2 and this is hydrogen. Here one hydrogen is added to this group, so we will be getting acetaldehyde ammonia. Then there is a removal of water molecules takes place and we will be getting CH3 CH NH. This is aldehyde. Second reaction is when formaldehyde, this is formaldehyde, it's react with ammonia, 6 molecules of formaldehyde react with 4 molecules of ammonia, it gives hexamethylene tetramine, CH2 6N4. This is 6 methylene group, so hexamethylene, 4N nitrogen is present, so tetramine. Tetramine. This compound also known as urotrophin. This is used as a medicine to treat urinary infection. The structure of urotrophin is here nitrogen, this is nitrogen, CH2, this is the structure of urotrophin and it is used as a medicine to treat urinary infection, and also nitration of urotrophin under controlled condition gives an explosive that is called as the RDX. RDX means research and development explosive. This is very important question. Next one is reaction with hydroxylamine, acetaldehyde CH3, C double bond O and hydrogen. This is acetaldehyde. When it is treated with hydroxylamine, this is hydroxylamine, it give an oxime, CH3, C double bond NOH, and here hydrogen, and here, and this is removed as the water molecule. So this is the oxime which is formed when acetaldehyde react with hydroxylamine. Next one is reaction with hydrogen acetone, aldehyde and ketone react with hydrogen. This is H2N NH2. This is called hydrogen. And here also there is a removal of water molecules takes place. This oxygen and this is removed as the water molecule. So we will be getting CH3, C, CH3, double bond, N, NH2. This is actually N, NH2. This is called as the acetone hydrosol. So when aldehyde and ketone react with the hydrogen, they form hydrosol. Next one is reaction with the phenyl hydrosine. aldehyde and ketones when it is react with the phenyl hydrosine. This is phenyl hydrosine. And it form phenyl hydrosine. And here also there is a removal of water molecule, and this is removed as the water. So remaining CH3, C, CH3, C double bond, N, NH, C6H5. Name of this compound is acetone, phenyl hydrosine. So phenyl hydrosine, when it is reactive with the carbonyl compound like aldehyde and ketones, it form phenyl hydrosine. Next one is an important naming reaction, that is Cannizzaro reaction. Cannizzaro reaction is a best example of disproportionation reaction. The presence of concentrated aqueous or alcoholic alkali aldehyde which do not have alpha hydrogen. Aldehydes which do not have alpha hydrogen undergo a self-oxidation and reduction to give a mixture of alcohol and salt of carboxylic acid. So this is known as Cannizzaro reaction. For example, benzaldehyde C6H5CHO. When two molecules of benzaldehyde, the presence of alkali sodium hydroxide, it gives C6H5CH2OH and C6H5COONA, and this is benzyl alcohol, and this one is sodium benzoate. So two molecules, when it is undergo reaction, the presence of sodium hydroxide, one molecule is reduced to benzyl alcohol and one is oxidized to sodium benzoate. Let us see the mechanism for this reaction. This reaction involves in 3 steps. The first one is attack of OH on the carbonyl carbon. This is the step 1. That is, the OH, the base which we added, this base attack the carbonyl carbon. For example, C6H5 C double bond OH. This OH, the base which we added, attack this carbonyl carbon. This 2 electrons shifted to oxygen atom. So we will be getting C6H5COH O minus. Second step is Hydride Ion Transfer. C6H5COH hydrogen, this O minus. From here, this electron shifted to here. With these electron, this hydrogen transferred to the carbonyl carbon of the another molecule. So we will be getting C6H5, this, then C double bond OH plus C6H5CH2 O minus. Next one is third step. Here proton exchange takes place, that is C6H5 C double bond O OH, and this is C6H5 CH2 O minus. This proton is transferred to here, so we will be getting C6H5 C double bond O minus plus this compound C6H5 CH2 OH, and alcohol takes place. So Cannizzaro reaction means aldehydes which do not contain alpha hydrogen atom undergo self-oxidation and reduction to give mixture of alcohol and salt of carboxylic acid. So when two molecules of benzaldehyde react in the presence of alkali sodium hydroxide, one is reduced to benzyl alcohol and another one is oxidized into sodium salt, that is sodium benzoate. It takes place in 3 steps. The first step is attack of OH on the carbonyl carbon. This OH, that is the base which we added, is attack this carbonyl carbon so that we will be getting a ion. Now in second step, this hydride ion, that is the hydrogen along with this electron is shifted to this carbon. Just it attack the another carbon, carbonyl carbon, so that we will be getting C6H5 C double bond OH plus with a negative charge. Now the third step here, proton exchange takes place. Proton exchange takes place so that we will be getting a benzyl alcohol and also an acid, benzoic acid. Next one is crossed Cannizzaro reactions. Crossed Cannizzaro reaction means when two different aldehydes, that is C6H5CHO benzaldehyde, another one is CHO formaldehyde. When these two different aldehyde undergo reaction, the presence of sodium hydroxide and alkali, one is reduced into alcohol, another one is oxidized into its corresponding salt. So it form benzyl alcohol C6H5CH2OH plus sodium formate HCOONA. This is benzyl alcohol, sodium formate. So crossed Cannizzaro reaction means two different aldehyde which do not have the alpha hydrogen combined together, and one is reduced into benzyl alcohol and another one is oxidized into its corresponding sodium salt. Thank you. Test for aldehydes. The first test is Tollens reagent. Tollens reagent is nothing, it is a ammoniacal silver nitrate. So this reagent is an ammoniacal silver nitrate solution. When this Tollens reagent is added to this aldehyde, and we will be getting a bright silver mirror, and this silver mirror is formed due to the formation of silver metal, and this test also called as silver mirror test for aldehydes. And second test is Fehling solution test. Fehling solution is a mixture of Fehling solution A, Fehling solution B. Fehling solution A is aqueous copper sulfate. Fehling solution B is alkaline solution of sodium potassium tartrate. When this solution, Fehling solution, added to aldehyde, a blue color solution is changes into a red precipitate. Here oxidation state of copper is 2+, and from 2+ it is reduced to +1 state. So cuprous oxide is formed. The next one is Benedict solution. Test with the Benedict solution. Benedict solution is a mixture of copper sulfate, sodium citrate and sodium hydroxide. When aldehyde added to this Benedict solution, here the copper 2+ is reduced to cuprous oxide by aldehyde. So here the blue color solution is changes into red color. The last one is Schiff's reagent test. When dilute solution of aldehyde added to Schiff's reagent, it gives a red color. With the Schiff's reagent, it gives a red color solution. So these are all the tests to identify the aldehyde.